I've been replacing my old home server with this Intel N100 mini PC. The old one was this MSI Windbox I bought new in 2012 or so, which was still running CentOS 7, so its upgrade was kinda overdue. I'm going to install Proxmox on the new one and will recreate my old home server as a virtual machine running Alma Linux. I'm going to take the 1TB hard drive that I upgraded the Windbox with some 7 or 8 years ago and put it in the new one to be just the data drive for the virtual machine. Furthermore, I'm going to build a Windows 11 virtual machine for gaming. Let's get started after the intro.
It's the anarchy with me on the exciting guy!
Alright, let's start installing Proxmox. Sure, I agree. Target disk is the internal NVMe drive, that's all good. I'm in the Netherlands, check. Password. Give it a clear name. Yeah, that'll work. Alright, let's go. Seems good. Let's check that web address. You don't have a subscription. You'll see this message each time you log in without one. It's no issue, it's fully functional, and if you have the means to support a project, you should get one, but you don't need to. Let's open our server object and disable the enterprise repositories. And add the no subscription repo. Check for updates. Alright, let's install those first. It opens up a console in which you just have to press Y to continue. Alright, that worked. Reboot? Well, let's do that. We'll have to wait until it comes back up. Seems to be back. We've got some default data stores, I guess. Not sure how you would call them in Proxmox. One for backups, ISO images and container images, and one for virtual machines and containers. I have some images on my current server, so instead of downloading them from my server and uploading them in here, I'll open a console and pull them directly from the old server. The ISO store is available on the machine at /var lib vz template ISO. Let's get the Windows 11 ISO first. You see, both are connected at gigabit speeds, but the old server can't really manage that, so we're limited to just over 20 megabytes a second. I'm also going to upload the VirtIO driver CD for Windows. Let's just do that through the web interface, since that's on my laptop right here. Alright, let's get started with the Windows 11 VM first. Click Create VM. Give it a name, select my Windows 11 ISO and select Windows 11 from the list. Also add a second drive for the VirtIO driver CD. I do want the QEMU agent to be enabled so we can monitor the machine from Proxmox. Well, EFI storage and TPM storage, there's only one option on this install, which is fine. I would like a bigger disk than presented here. 32 GB seems a bit low for a Windows 11 machine. Also enable write-through cache and click the discard box so QEMU knows when storage space gets freed up. I'd like 2 cores and host CPU pass-through. 8 GB ought to be enough for our use case. 4 seems a bit low and the host machine only has 16 in total, so yeah. Network is perfectly fine. Finish. Alright, let's open the console. And here's our Windows 11 installer. Oh no, no hard disk! That's where the VirtIO driver CD comes in. The one for Windows 11 please. Cool, we've got a 100 GB hard disk. Now we can just install like it's a regular PC. And there's our Windows desktop. Let's open that VirtIO driver CD and install all drivers. Next, I want the agent that's on the same CD. By the way, I downloaded this driver CD from here. I'll put a link in the description for those who need it. With that out of the way, we now have everything working as it should, but we don't have any graphical acceleration active. Just a basic graphics adapter, as you can see here, not good for gaming. In my testing, I found that virtual GPUs just don't work at all on Windows. So we're going to pass the physical GPU to the virtual machine. But first, let's enable remote desktop. Alright, now give myself a password so I can actually use it. Because we have the guest agent running, we can see the machine's IP address on the summary page. Let's copy that. Now I can use the remote desktop client to log into the machine. I'm on a Mac right now, so I'm using Microsoft's Windows app. Boom! A nice 1080p desktop. Cool. But there's still no GPU acceleration. To show you just how bad that is, I'll try to run the game Broforce. First, copy it from our living room Beta Sierra system. Yes, this is a legally bought copy from GOG. You see, even the menu is horribly slow. I'm not even trying to get into the game like this. So yeah, let's turn the machine off and fix that. By the way, there's chapters if you don't care for the GPU stuff. Kudos to Dirk Seaman for his great article on getting this to work. I will simply follow his lead on this. First, we'll edit the display on the virtual machine and set it to none. This is why we needed remote desktop to be enabled, because we won't be able to see the screen anymore afterwards. And yes, the display needs to be removed because the pass-through GPU will not work in Windows if there's any other active adapter. Next, we'll install a Linux driver for the Intel GPU in this N100 box that allows for sharing with virtual machines. Update and install Git, sysfs utils, PVE headers and macutil. All done. Next step in the tutorial is removing the existing i915 SRIOV drivers, which I don't think are there because no one has installed them yet. But hey, better safe than sorry. Alright, clone the Git repository for the i915 SRIOV driver. Install some build tools and DKMS. I guess we could have done that before, but hey, if it works, it works. Right, enter the directory for the new driver and add it to DKMS. For those who have no idea, DKMS is a system that will recompile the drivers you feed it on kernel updates, or well, at least it will try to do so. So yeah, kernel updates could break whatever we're doing right now. Pre-install the driver, run the macutil command, which will add a signature for secure boot. You don't need it if you have that disabled. Update grub to enable Intel I/O MMU and some other options. The max VFS option tells the kernel to split the GPU into 7 virtual ones next to the main one. Add a line to the sysfs.conf to tell the system to actually open those 7 virtual GPUs. And yes, this means I could potentially run 7 virtual machines using the same GPU at once. Alright, let's reboot. Let's move over to the actual screen of the mini PC. Press any key for mock management. Well, let's do that. Choose Enroll Mock. Yes, please. Alright, back in business. Boom! 8 GPUs. The first one is the real one connected to our mini PC. The rest we can give out as we please. Back to our virtual machine settings. Add a PCI device and choose the first virtual GPU. Tick the primary GPU box to let the system know what it's for. And boot the VM. We can't watch the console anymore, so we'll have to wait until we see the machine's IP address right here. Let's connect. Download and install the GPU driver for this N100 box. This is just a regular driver, nothing special about it. Well, look at that! Intel UHD graphics, woohoo! The task manager now also shows an actual GPU. Let's try to run Broforce again. That's quite a bit better, right? It's already playable, but not a great experience through remote desktop. To get the best results, I'm going to install Apollo, which is a game streaming service. Just install like anything else, and make sure to keep the virtual display driver because we're going to need it. On a physical PC, you could just stream the output to your monitor. We need this display driver to connect to our virtual GPU as if it's a regular display. Alright, reboot our Windows PC. Back in, let's run Apollo. Under audio and video, I'll select headless mode. Okay, booting my Linux PC so I can capture this part a little easier. Run the Moonlight client and connect to the Windows VM. The first time this will give me a pin code I will have to enter into Apollo. Give it a name as well. And now I can open the virtual display. Wait, let's set it to 1080p. That's better. So this works, but we don't have any sound. Let's fix that as well. Apollo needs to tap into an existing audio device, so we'll add a dummy one. With the VM shut down, click Add, choose Audio Device and set it to Dummy. It doesn't actually have to do anything. Boot the VM again and reconnect. Oh yeah! Well, this works pretty good, right? How about something a bit more demanding? Here's the Falconeer at low settings but 1080p. About as fast as it will run on this N100 box.
Now let me see some evasive rolling. You can do this by dashing while turning.
And here's flat out. And yes, this really is running on the virtual machine, connected over network via Moonlight and Apollo. It's hardly any worse than directly on the machine, which is quite incredible since the GPU is also handling the stream and the machine has only 2 of the 4 cores available. Cool! Well, I think my wife will be able to play Stardew Valley with her friends on here. So with that working now very well, let's start actually replacing my current home server. It's nothing special, just a Linux machine with some Samba shares. I've been running some other stuff on it, but that's its main purpose. A container should actually be able to handle this, but since I want to add the hard disk from the old system to this virtual replacement, I'm going for a full virtual machine again. Upload the Alma Linux installation ISO, create VM, let's just call it file server, attach the ISO, I do want the agent, storage, tick the disk card box again, don't care too much about the rest because it will only be a system drive. Single core should be fine here. I do want the host CPU. 2 gigs of RAM should be enough for this. Alright, here's the installer. Choose our installation destination. I want custom partitioning because I don't want a home partition. Click here to create a basic layout automatically. Oh, it doesn't even suggest a home partition, probably because the small 32GB disk size. Let's create a user for myself. Hey ho, let's go! Okay, finished. No guest agent out of the box. Let's open the console again. QEMU guest agent, that seems about right. That's better. Can I SSH into it? Yep. Let's change the host name. Log out, log in, yeah, that's better. Okay, instead of doing the Samba configuration by hand, like I have done on my old server, I'm going to install a nice web interface for it. Red Hat has the cockpit interface which can be extended with plugins. 45 Drives has a nice looking file sharing plugin for that, so let's give that a try. First add the 45 Drives repository. Let's update before we install anything first. Why did we get OpenSSL from the 45 Drives repository? Ah well, let's just do it. Alright, let's install those cockpit plugins. That seems to have the actual cockpit interface as a dependency, which is what I hoped for. Okay, enable the cockpit socket. It works! Did I really have to change the login page to this Houston command center? Not a fan, but hey, let's not nitpick here. So here's Cockpit. Open the file sharing plugin. Access denied. It tells me to add include is registry into smb.conf. So let's do that. Cool. The actual Samba server isn't installed yet, but let's do that first then. Still an error. Oh wait, I don't have administrative privileges yet. Ah, no error. Import from smb.conf? Cool, nothing happens. Oh yeah, let's actually start Samba. Sorry. Still nothing? Maybe a reboot helps? Not really. There should already be a home share, which is simply mapped to your username. But Samba uses its own authentication, so let's create a Samba password for myself. Click Identities, Users, Myself and push Set Samba Password. My Mac doesn't see the server yet. Is the Avahi daemon running? Oh, it's not even installed. Well, let's fix that then. You don't really need it, but it helps other systems to find the server. Alright, up and running. And there's my file server. Why won't it connect? Ah yes, let's add Samba to the list of firewall exceptions. Right, so now it's working, but I can't copy anything to my own home dir. Ah yes, SE Linux. Luckily it's pretty easy to fix that from the cockpit interface. Apply solution. That's better. So Samba itself is functional. Let's add the hard drive from my old server. Before I do that, I boot into it from a stick to remove the OS partitions and resize the data partition to fill the entire disk. Yeah, it doesn't have to boot anymore as long as the data is still available. And yes, I made a backup just in case. Oops, I didn't anticipate on a 6-hour wait. That's what you get from working with old school physical partitions. Done! Well, everything seems to be here. Let's shut it down and remove the drive. Voiding my warranty for the second time since I bought this box. There's my drive. Remove the cage. Okay, move over to the new N100 box. We can add a SATA drive at the bottom, which will be very close to the NVMe drive in this box. I'll have to monitor drive temps as there's no airflow in this part of the box either. Right, close it up. And turn it back on. LSBLK shows the hard drive as SDA. In /dev/disk/by-id, we see the full ID of the drive. I'm going to map that to my Alma Linux virtual machine. QM set machine ID -SCSI2 and the full path to my disk ID. Okay, let's see if we can find it in the virtual machine. There it is. Let's get a partition UUID of my data partition. That's this one. Let's add that to fstab and map it to /home. And mount. Looking good. Of course, Samba is now not working anymore because SE Linux doesn't like the new home partition that came from a machine with SE Linux disabled. Let's run a restore con at /home. Woohoo! My old files are back! Yeah, it's messy. Let's just try to add a public share from here. Guest OK, read only. Yeah, something like this. Nothing. No shares visible without logging in. Right, I'm not the first one with this issue. So apparently you'd have to create a Samba registry yourself before you add a registry line into smb.conf. Let's do that. Remove the line, import smb.conf into the registry. Check. Add the line again. Let's reload just to be sure. Still nothing. Let's just use a graphical interface to make things easier. Let's reboot again, see if that helps. I mean, we're using a registry now, right? Finally! Yes, this is what I want to see. Right, add that public share again. Apply. Still not working? Come on! In my old config I have these two lines, which I have just added in here. Not sure if you need both, but now it works. Well, you may see my music collection. Let's add another share I had in my old config, pointing to MP3 backups of that same collection. And that one works right away. Phew! I can't say I'd recommend this interface. I think manually editing the smb.conf is a lot easier. But at least, if I want to create a new share, I now have an easy interface. We have hardly touched the cockpit interface itself. Let's go through some options. There's an easy way to enable updates. Let's do that. Once a week at 6 AM is fine. I'm usually still in bed at that time. We've got some easy account management. There's some applications you can install, which are just cockpit plugins. Let's do storage. So now we have the option to configure storage from within cockpit. Red Hat's own plugins work very well, to be honest. I guess it's time to wrap it up. This Awow AK10 box is a very nice replacement for the old MSI Wind I used before. I can't find this exact model online anymore, but Chewy's Hero box seems pretty similar and you can get that very cheap today. Just has a bit less memory on board, however. I guess that's all I have for you today. I might add some things like a VPN server, but let me know in the comments if you want to see me struggle with that. Thank you very much for watching. Until next time.